Okay, good day everyone. I'm honored to be part of the 2020 IEEE 7 International Conference of Engineering, Technologies, and Applied Science, or ICTS. I'm Janelle Mokalisang presenting, and one of the authors of iSmoker, so a machine vision-based nose in nose inference system of cigarette smoking detection using convolutional neural network. So, as you can see, cigarette smoking is a single leading cause of preventable death in the world today. So, according to World Health Organization, among the 1.1 billion smoker globally, 80% of these smokers live in the low and middle income countries. So, in the Philippines, at least 16 million Filipinos reported smoking cigarettes amid the campaign against tobacco products due to various concerns about their adverse health effects. So the purpose of this study is to identify the smokers within the area, a smoke detection device that can detect smoker in prohibited smoking areas and that can be installed in a large public prohibited smoking area. So with that, the researcher come up with a methodology. So first is the objective of the study is to create a smoker detection system using deep learning or YOLO version 3 that aims the use of visual medium on image and videos for detecting. So this study will benefit both government and private sector from the strict implementation of non-smoker regulation and prohibited smoking areas. So on as you can see on the methodology, wherein we or as a researcher, so we have formulated the data preparation for collection and annotation, and then after that, get the necessary libraries for installation, and then have detection model training, and then if there's a decision losses, if yes, and then go back to the data sets, and then if no, so model will be evaluated, and then creating a GUI development, and then after that testing of the model. So upon doing the steps on methodology, so we have conducted a smoking cigarette data sets wherein wherein the study gathered uh, image of people smoking cigarettes. So the data sets shown in the figure is different photos of a smoker from any ages, and then the study used were Pascal VOC format and labeling tool for annotating the data set. So the study used 300 image, and then 70% of the for training, and then 30% for the evaluation. So after this, so we check for the libraries, and then the libraries installation, and then the GUI. So the following codes are used to install the needed libraries for us to test it, and then after that we train the detection of model. So use for transfer learning from pre-trained to YOLO version 3 model, and then the training to improve the accuracy of train custom models, so to attain the accuracy of 90%. And then also upon uh, training the model, so the researcher also created a GUI, or graphical user interface, wherein it means to communicate to a computer for computer application using graphical symbols. So instead of typing the instruction, so the study can enable to use a GUI, wherein you just need to import the image that you want to to test or import a video, or you can also an open webcam or live feed video. And then after that, we come up with this result, uh, wherein on the diagram wherein there is a total of 50 uh, result range from 63 to 98%. So based on the data, the most accurate train model that can be used is in from epoch number 48 with a training accuracy of 98.10% validating accuracy. And then on the 98.22%, which are the highest value shown on the diagram here, wherein you can check the orange line. So that's it. And then the evolution model, wherein in total there are 30 models generated based on the gathered result. So the train model from uh, epoch number 28 has the highest MAP or value. So it also shown here on the figure below, the green one, wherein this model will be used for the system. So on the testing, so these are the photos that we uh, test. So the study trained to model the highest MAP value. Custom object detection was detected presenting 30 different image, and then three of them, three different also videos, and live detection testing was conducted using laptop and webcam. So out of 30 image that we tested, so 27 of them are correctly detected. And then using the formula for the accuracy, wherein accuracy is equal to number of samples, then recognized correctly over total number of samples multiplied by 100%. So on the testing that we test 30 image, so three of them did not detected. So from 30, it goes down to 27. So 27 over 30 times 100%. That's why we get 90% of it. And then after that, we also have a video testing. So although I just grabbed the screenshot, so uh, it shows that a successful detection of cigarette in the video. And then in this part, the instance that the cigarette was not easily detected due to the angle. So sometimes there are frame on the video that didn't get by our system. It's because on the angle. So I think we will consider also with that one on the near or on the other research. So and then on the quality and also for the quality of the video itself. So here, so based on the angle, we did not detected this one, but if you put the cigarette on the mouth and then based on the angle that put that uh, the system considered is we recognize that there is a cigarette. Same thing with this one. So upon doing those upon testing, so we and then having those results, uh, the researcher finally had a conclusion about the research. So the study proposed system that can detect smoker in an area. So the system used a deep learning algorithm to optimize and to detect people that are smoking cigarettes. So also, the study conducted model training and testing of collected database or image and videos concern smoking cigarettes as a specific detection. And then model training and validation result range from 63 to 98%, considering most accurate trained model can be used from the epoch of 48, so which has 98.1, 98.10%. And then training accuracy and 98.22, so validation accuracy. So the experiment result shows that the generating detecting system has a higher average accuracy. So if ever the government want to use this uh, system, I think we can say that it worked 90% above. And then but the study is limited to a detection of the cigarette to recognize possible smoker. And any forms of smoking like e-cigarettes, smoke pipes, and the likes will be unrecognized, since the system is only for cigarette. And then improvement of this study could be done in the future. So first, by adding image data set of other forms as uh, aforementioned, and second is application of the system and hardware for more complete setup, since what we did only is the software. So that's it, our conclusion. So I would like to thank my uh, I would like to thank TUP and also my other co-researcher, Nino Merencilla and Michael Angelo Ligayo, and then Mark Miligrito, and also Ryan Dihada. So that's it. So thank you for having me, and then one of the presenter in the 2020 IEEE 7 International Conference of Engineering Technologies in Applied Science. Mm, thank you, and then have a good day.